Okay, some more things you should know from the grade 10 quadratic relations unit are the equations of quadratic relations. And so we looked at the quadratic relations in 3 different forms. We looked at it in standard form, vertex form, and x-intercept form as well. And each of these different forms gave you different pieces of information. So for example, the standard form would help you identify the y-intercept easily. Remember, the y-intercept of an equation is found by setting x equal to 0. And you know that if you set x equal to 0, this term would be equal to 0, this term would also be equal to 0, and so all you'd be left with is the constant value at the end. So when the equation is in standard form, it helps you figure out what the y-intercept is easily. When the equation is in vertex form, the benefit is that you can find the vertex easily. Okay? So it's easy to identify the vertex and also to identify what the transformations are to the base quadratic function. So remember that the base quadratic function looks like this. Okay, no transformations applied, but as you apply different transformations like a, h, and k, those help you graph the new function. Okay, so what we're going to be looking at are questions where we're looking at the graph of quadratic relations that have transformations applied to them. And what you'll notice is that the a value will either vertically stretch or compress it, or vertically reflect the graph. The h value will shift the graph to the left or to the right, and then the k value will shift the graph up or down. Okay. X-intercept form, what was the benefit of knowing the quadratic relation in x-intercept form? It was easy to figure out what the x-intercepts were. Okay, so in this case, our two x-intercepts would be x equals r and x equals s. So those were some of the benefits of the different forms of the quadratic relations. Okay, our first example in terms of graphing, we're going to be graphing two quadratic relations. Here's the first one, y equals x minus 4 squared minus 1. And the second one is y equals negative 2, x plus 2 squared plus 3. So we're going to be graphing these. So let's start with the first one. And so some of the information I know from the first one is that the vertex of the function is going to be at 4 and a negative 1. Remember that horizontal transformations always look backwards. And so the h value is actually positive 4 and not negative 4. It says negative in the brackets, but it's actually moving to the right 4 units. Okay, if we think about what the transformations are here, this is a horizontal shift to the right 4 and a vertical shift down 1. So that means that the vertex that would normally be at the origin has moved to the right 4. That's where this comes from. And down 1, which is where that comes from. So what I'm going to start by doing is plotting the vertex. I'll use a scale of 1s again. So I'm going to move to the right 4, and I'm going to move down 1. And there's the vertex of the function. So that's either going to be the maximum point or the minimum point of this quadratic relation. The next thing I need to look at is the value of a. And I'll notice that the value of a here is equal to 1. So what that tells me is my step pattern is not going to change. Okay? And remember that all that's happened is that the quadratic relation has shifted to the right 4 and down 1. The actual shape of the function has not changed. So what I'm going to do is move from the vertex. I'm going to move over 1 and up 1. Go back to the vertex. I'm going to move over 2 and up 4. Go back to the vertex and move over 3, and I'm going to move up 9. 5, 6, 7, 8, 9. And remember that a parabola is symmetrical, so any shape of the graph that you have to the right of the vertex will look exactly the same to the left of the vertex. So over 1, up 1, back to the vertex, over 2, up 4, back to the vertex, over 3, and up 9. And there's the very symmetrical looking parabola that we need. Okay, again, don't forget to label your function, your quadratic relation. And there you have the first one done. Okay. The second example that we're going to be looking at is y equals negative 2, x plus 2 squared plus 3. So I'm just going to flip this over like this. And again, I'm going to just draw my grid and we'll talk about what this graph will look like. And we'll talk about how the step pattern will be changing in this case. And so again, I'll start by listing what the vertex is. and we'll talk about some of the transformations. Now, remember when you are looking at transformations, you should start right from the beginning and then move across to see how it changed. And so, remember that your original quadratic relation looks like y equals x squared. Now, a bunch of different transformations have been applied to the new function. So, one of the things that have happened is a vertical reflection, which means the graph is going to open down. It's also been vertically stretched by a factor of 2, which means the graph is going to look narrower because it's been pulled vertically. It's also going to be shifted to the left 2 units, and it's going to be shifted up 3 units. So, based on the shifts left and right and up and down, we can tell where our vertex is going to be. So, the vertex in this case is left 2 and up 3. So, at -2 and +3. So, I'm going to start by plotting that. So, I'm going to move to the left 2 and up 3. And there's the vertex of the function. And from there, I'm going to use the step pattern. So normally our step pattern is over 1, up 1, over 2, up 4, over 3, up 9, over 4, up 16. That's what we normally have. But in this case, we have an a value of -2. So we need to incorporate that in this part of the step. So when we're moving left and right, that's not going to change. But when we're moving up, or in this case down, that is going to change. All of these step values are going to be multiplied by -2. So I'm going to multiply each one of those values by -2. So instead of moving up 1, I'm going to move down 2. This is going to become -8. This is going to become -18, and then -32. Obviously, not all of these points are going to fit in my graph, but I'm going to try to put in as many points as I can. So using the value of a, I figured out what the new step pattern is going to be. So instead of moving up, I'm going to move down. That's what the negative here indicates. And I'm going to move down twice the amount that I would have normally. So from the vertex, I'm going to move over 1, down 2. Then I'm going to move over 2, and I'm going to move down 8. So 2, 4, 6, 8. Is that right? Yes. And I don't think 18 will fit, so that's as much as I'm going to do. I'll continue to do the same thing on the left-hand side of the vertex since a parabola is symmetrical. And so the left side and the right side should look the same. And there's the graph of the function. Clearly it looks much narrower than the first graph that I had. Okay? And normally you want to try to draw it a little bit more accurately. Whoops. This is not as accurate as it should be, but you get the idea. Okay, don't forget to label your function. And there you have it. Okay, so the next part we're going to be looking at is quadratic expressions and quadratic equations. So this was another part of the quadratics unit that you looked at last year. And there were several things that you looked at. You looked at expanding expressions, you looked at factoring expressions, and you looked at solving equations. In terms of expanding expressions, you probably had 2 binomials being multiplied together, and you had to expand this using the first term and everything in the second brackets, and then the second term and everything in the second brackets, and then you collected like terms, and then you simplified. We'll do some examples of that. Then you also looked at factoring, and factoring involved you looking at something in this form. And then what you had to do was actually try to figure out what the factors would be that look like this in order to actually try to work with it. And if I actually change this, that expression, you'll notice that this is actually the factored form and this is the expanded form of the same problem. Okay. We also looked at solving equations. The last 2 things here we're going to focus more in detail in one of the other lessons, but I just want to give you guys a brief review of it just so that you can try to remember it. Here are some examples. The first example looks at expanding and simplifying, and the second example looks at factoring fully. So I'm just going to grab a piece of paper. And let's start by expanding and simplifying. So for the first question, remember that the word expand means that you're trying to multiply things out and then make it, and the word simplify means that you're going to try to make it pretty. And so the first one I have x minus 2 squared. An exponent of 2 indicates that you're multiplying something by itself twice. And then from here we're going to use the distributive property to expand this. So we're going to multiply x with everything in the second brackets. and then negative 2 times everything in the second brackets as well. And so if I use the distributive property and I just expand and simplify, I get x squared minus 4x plus 4. There's also a shortcut for doing this as well in case you sort of remember it. And the shortcut was that you would take the first term and you would square it. You would take the last term and you would square it. And then to get the middle term, you would multiply two terms together and double it to get the middle term here. So if you remember that, great. If you don't, it's not a big deal. You know how to expand in different ways. Okay, in part B, this one's a little bit more complicated because you have a pretty nasty looking coefficient at the front. So I'm going to ignore the coefficient, and I'm going to use the distributive property with the rest of it. And again, you can actually skip this step that we did in the previous question, and you can go straight to this step just by applying the distributive property. So that's what I'm going to do in part B. So I'm going to multiply 2x with everything in the second brackets, and then I'm going to multiply negative 1 with everything in the second set of brackets. And so if I multiply out 2x, I get 4x squared plus 6x. If I multiply out negative 1, I get minus 2x and then minus 3. And if I simplify what I have inside the brackets, I have 4x squared plus 4x and then minus 3. And now I can apply the coefficient here. And so I'm going to multiply 3/4 times 4x squared, and then I'm going to continue that across. And so that'll give me 3/4 of 4, which is just 3. That's 3x squared. 3/4 of 4 again is just 3, so that's 3x. And 3/4 of negative 3, that would give me negative 9 over 4. So that's expanding and simplifying. Okay, then we have some factoring problems. And so remember that when you are factoring, the first thing you want to think about is what the common factor might be. If there is a common factor, you want a common factor. If there is no common factor, then you have to think about what kind of problem you may have. So in the first question that we have here, we have 3x squared minus 9x minus 120. And I know that 3 is divisible by 3, 9 is divisible by 3, and 120 is also divisible by 3. So let's try to common factor out of 3. And we're left with x squared minus 3x minus 40. And then from here, what we have inside the brackets is a simple trinomial. So trinomial because there's 3 terms. Simple because the coefficient of the x squared term is just 1. And so I'm going to use the product and sum to help me try to factor this. So the product in this case is negative 40. And the sum is negative 3. And so I need two numbers that multiply to negative 40 and add to negative 3. And I believe negative 8 and 5 work. So negative 8 times 5 is negative 40. Negative 8 plus 5 is negative 3. Factoring this is pretty straightforward. And so I get 3 times square root of x squared is x. And then my two terms here, or two numbers here, will create the rest of the factors that I need. And there's a factored form of the first one. Okay, the second example I have here is x squared minus 16. And so if you look at this one, it's a binomial because there's only 2 terms. And there's only one kind of binomial that we can actually factor, and that's called a difference of squares. So there has to be a difference, and the 2 terms here have to be perfect squares, and in this case it works. So what I'm going to do is factor them out. And to factor out a difference of squares, you square root the first term, and you square root the last term, and you have plus and minus in the middle. And remember that the signs in the middle are opposite, and that's how the middle term disappears, and that's how you're left with just a binomial. Okay, and there you have it. That's a review of all the quadratics, quadratic relations, equations, and expressions that you looked at from last year.